Solving equations with radicals. In this presentation, we're going to take a look at how to solve equations that either have a cube root or a square root. And before we begin, let's talk about a notational item. And that notational item is going to be the fact that we are traditionally used to seeing the square root of x written with the radical symbol, but we could also see it written with an exponent. And we have to realize that the exponent, 1/2, actually represents that we're taking the square root of its base, or in this case, the square root of x. So in a similar fashion, instead of seeing the cube root of x, we could see x raised to the exponent of 1/3. So anytime we see an exponent that's a fraction, that's going to tell us we're going to be taking the root of that equation. And if the denominator is a 2, that will be a square root. If it's 3, it's going to be a cube root. Those are predominantly going to be the roots that we're going to be finding when we're solving with radicals. The other thing is going to be that there's going to be 3 different forms that we're going to be trying to identify. And the 3 different forms are going to be when we have a radical, meaning like a square root, equal to a constant, all right? Or we could have a radical equal to the same radical. That would mean like a square root equal to a square root. Or when we have a radical equal to a radical plus a constant. This is kind of our most challenging form. And this is close to this form where you have a radical equals to a radical. But when you see plus another constant, that's going to throw a slight change into our procedure. So with that, let's go ahead and take a look at 3 examples, one of each here. And our first example is going to be the example that would be if we have a radical, all right, equal to a constant. Now, realize at first it doesn't really look like that, right? Because based off our conversation, there's our radical. We see the 1/3, which is telling us a cube root. But this looks like radical plus constant equals constant, which really isn't one of our 3 forms. But that's why one of the first things we want to do is be able to simplify our equation. So we actually want to take this equation here and simplify it simply by taking and subtracting 1 to both sides. Now that's going to give us the statement x to the 1/3 equals 4. Or in other words, the cube root of x equals 4. From here then, what we're going to end up doing is we're going to actually apply the inverse operation. So what's the inverse of taking the cube root? That would actually be cubing. So we're going to actually cube both sides of the equation. Based off our properties of exponents, power to a power means we multiply. And what's nice here, we see that 1/3 times 3 is 1. So that just gives us our x, which again makes sense because we are applying the inverse operation. And then 4 cubed is 64. And again, that comes from 4 times 4, which is 16, times another 4, which is 64. If we check our answer, that would just simply mean we're going to substitute a 64 in. Cube root of 64, we just said is 4. 4 plus 1 is 5. That checks out. So this is one form, all right? And again, that's if you just see one radical, all right? If you just see one radical, then you want to isolate it using inverse operations to get your answer. Now in this case, we see we have 2 radicals. We got a square root equal to a square root. So this is actually one of our nice solving scenarios, but it has a little bit of a twist at the end. So if we think about this statement, this is saying the square root of something is equal to the square root of something, which tells us then basically that these somethings, in this case 2x plus 5 and x minus 3, those 2 statements have to be equivalent, or they have to be the same. We could also get that same result if we would go through and square both sides. So if we square both sides of the equation, we would also end up with 2x plus 5 equals x minus 3. However you want to think through that problem. Now from here, I'm going to subtract an x to both sides. I'm going to subtract 5 from both sides. And I get x equals -8. Now, one of the things that we talked about is we want to kind of like envision that we're checking that answer. And so if you see -8 minus 3 is -11. And if we put a -8 in here, this gives us -16 plus 5, which is also -11. So at first, that seems like it's the right answer. But unfortunately, it's not. -8 in this case, actually is not defined for the expression x minus 3 because it produces a negative value. So, in this case, we would actually say no real solution. We're not going to actually try to identify like an imaginary or anything like that. When we get a value that's going to be undefinable when we put it into the square root or into an even root, we're going to then classify that as no real solution.